You probably think of a Dyson sphere as a structure that captures the sun's energy, but what would happen if you built one around a black hole instead? A global coalition of scientists are in pursuit of the answer, analyzing 6 different types of energy that we could hypothetically harness from a black hole. What they find could help us reveal what a next-generation galactic civilization might look like, and even help us locate those extraterrestrials in the process. For the uninitiated, prolific scholar Freeman Dyson first described his namesake Dyson sphere concept in a landmark 1960 paper. At the heart of his theory is a simple, but tantalizing, question: if a civilization grew large enough, and traveled far enough afield into outer space, how would it have enough energy to power itself? Dyson's answer is the Dyson sphere, or a hollow ball built around the sun, that would solve the space and energy problems, according to his paper. Therefore, it's a theoretical device that sits around an entire star and harvests its energy. Its goal is to help power a civilization whose energy demands have simply eclipsed their planet's natural potential. It's part of Dyson's broader suggestion that the search for extraterrestrial intelligence should set their sights on the kind of energy signature that such an item could discharge. Dyson spheres all tie back to a system called the Kardashev scale, which is based on how much energy a civilization consumes. Earth, for instance, is a Type 1 civilization under this rating system, because we only use the amount of energy available on our own planet. In the new paper, published earlier this summer in the monthly notices of the Royal Astronomical Society, the researchers ponder what it would take to power a Type 2 or Type 3 civilization, whose energy needs consume their entire solar system. How could Earth become a Type 2 civilization? In the most literal way, we'd have to harvest energy from not only the Sun, but from Jupiter, which is almost a star, itself, and everything else available to us in our solar system. The natural follow-up question is why we'd need that much energy in the first place. This, it turns out, is pretty easy to answer as we speed into the 2020s and beyond. Think about the energy required to carry more and more people into space as the world's billionaires venture outside of our planet, plus the energy demands for NASA's own ambitions to install people on the moon. Alternately, you can think about an entire world powered by electric batteries instead of fossil fuels. In the longer term, consider the concept of uploading people's consciousnesses to some kind of data storage center, as proposed in an episode of the dystopian anthology series Black Mirror. In San Junipero, 2 young women meet and fall in love from inside a server farm, while their bodies exist in vegetative states in the real world. Let's say an individual's memories and mind fit into 2.5 terabytes of storage, which is an extremely low estimate. That means there's a server farm somewhere with 20 billion terabytes, which is 20 million petabytes, or about 20 exabytes. That's 20 times the data that Amazon Web Services holds, and it's effectively the storage backbone of the entire internet at the moment. So, it's easy to see how much energy this electronic infrastructure alone would take up, let alone the heat sink and cooling to make sure all of the electronics can run safely and sustainably. This is the point at which an Earth far into the future might need to harness the full power of the Sun, and the point at which we'd become a Kardashev Type 2 civilization. Another civilization, with even higher energy demands than what we've outlined above, might decide to deploy a Dyson sphere around a black hole, which is where these researchers began their work. Their goal is to explore the power needs of a civilization making the jump from a Type 2 to a Type 3 civilization, which could be Earth in as little as 1,000 years, according to their scientific napkin math. But is it at all feasible to use a black hole as you'd harness the energy of the Sun or another star? In this paper, we consider and discuss 6 types of energy sources: the CMB, the Hawking radiation, an accretion disk, Bondi accretion, a corona, and the relativistic jets from 2 types of black holes, a non-rotating black hole and a rotating black hole, the researchers explain. This method, they say, is more intensive than previous attempts to study black hole energy harvesting, which have only explored the accretion disk, the structure of a black hole that you typically picture, or the cosmic microwave background, the electromagnetic radiation that remains from the earliest stages of the universe. Of all the considered parameters, the researchers conclude just the accretion disk, the corona, which is the plasma gas surrounding a black hole, and the relativistic jets are promising energy sources. How, then, could this civilization harvest the energy? That part requires thinking beyond just the Dyson sphere and expanding to a Dyson swarm or bubble. A Dyson swarm is a collection of individual, smaller harvesters of some kind, that could be solar panels used extremely close up, for example, that are loosely circulated. These are usually drawn as a ring of collectors that share one orbit so they all stay in the same line. This makes sense as a way to predict movement, create stability, and easily adjust or work on any individual unit in the Dyson swarm. This is only more vital if the energy source is a black hole rather than a traditional star. The swarm could be made of many individual collectors placed all around the different parts of a black hole in order to best collect from the accretion disk, the corona, and the relativistic jets. The researchers conclude by showing what SETI should look for if a Type II civilization is hypothetically using Dyson sphere technology to collect energy from in and around a black hole. This, they say, will likely be in the form of waste heat that we can observe with infrared spectrum technology. All black hole measurements may look roughly alike, but there will be abnormal peaks on those that are likely housing Dyson sphere technologies, the scientists say. Earth is far from using a Dyson sphere to harvest our Sun, Jupiter, or even a black hole. But by analyzing what such an object would look like and leave behind as excess heat, scientists are better able to search the cosmos for that signature, and find any new neighbors who are running Dyson spheres on their nearest black hole.
Thanks for watching, and don't forget to subscribe. Also, if you want to support Warthog Defense, please become our member and get early access to new videos, exclusive members-only videos, and become administrator in comment section. The membership link is in the description.
Rescues every day. We had a guy last week at 6 rescues in 6 days. He's doing the job every day.